Clean water is life. If you don't have clean water, then you have a sickly life.
We believe that people are getting sick from the water.
Life and death? Yeah, people do die from water around here, drinking bad water. There's, of course, no plumbing. They wash in the stream. They drink from a lagoon.
As you walk through the village and right outside the school, you see that all their wash water and all their wastewater is coming through the streets. That's an area where mosquitoes can breed and bring malaria, and also the wastewater could have the waste that you don't want to be in contact with.
This community does not have consistent electricity. They don't have running water.
It's got to be a situation where we're part of the solution. Matter of fact, I think it's our obligation to come up with the solutions.
Hopefully the impact is more kids go to school because they can get there during the rainy season and get home during the rainy season.
This is engineering. This is what engineers do. Come up with a solution and then try and make it work. Bravo. Thank you. Has to work.
There you go.
Clean water, energy, waste management, transportation. These are just some of the infrastructure needs essential to survival for any community. Student and professional members of EWB, Engineers Without Borders USA, are working with communities in the U.S. and around the world to improve critical infrastructure to help communities thrive.
That's what people need engineers for, is to fix the problems.
I just wanted to do something that could make a difference in the world, and I think engineering is definitely something that could lead to that.
It's incredible to think what we can do as engineers to impact the world.
EWB USA teams are working on a water resource project in Kenya, a solar power implementation in Nicaragua, and a pedestrian bridge in Ghana, and many other projects. Namawanga, Kenya is located about 200 miles northwest of Nairobi. There's no plumbing in the village. Some people get their water from deep water wells called boreholes. But others get their water from spring boxes, or even more unreliable sources such as hand-dug wells or ditches. Getting water can take up a big part of the day, and sometimes the water's not safe to drink. Environmental and mechanical engineering students with the University of Massachusetts are working with the Namawanga village to obtain clean water. The team must find a sustainable solution, balancing long-term reliability with limited access to tools and materials. Eventually, the team hopes to implement a new well.
Good morning. Good morning. The community has had quite a number of diseases. Dysentery, diarrhea. The source of the disease has been found, and we found that it's coming through water. Getting it clean has been the paramount objective.
How are you? Welcome. Yeah. Welcome. Welcome.
Village is great. Rabai, Gladys, Florence, I love them all. They're just so welcoming and so warm and friendly and everything. It's really nice. It's really nice being here.
We are here for the clean water, to kick out the dysentery from our areas. Thank you. We are very happy.
That's wonderful. Yeah.
The village leaders and the UMass team plan to evaluate the quality of the community's water resources.
The green, they indicate spring boxes.
The spring boxes.
Spring boxes that run year-round, and the pink are the spring boxes that dry up. You know, especially in this area and this area, they don't have a reliable water source.
Okay.
And that's important.
The water sources around here, they were all contaminated. I mean, if I or most North Americans drank that water, we would be sick in no time, I would expect. Our group proposes to you that you tell us what sites you want tested for potentially having a well.
But what we are saying is that at the end of the day, the objective would be to satisfy the water requirements for the community members.
Okay, these are 7 places for immediate testing.
Oh, 94. We're doing it. I guess what I take out of engineering, it's just important to be able to learn as much as you can to give it back to people. I mean, that's really why I'm doing it, because at the end of the day, I mean, we're giving people clean water. You can't put a price tag on that. You really can't. It's incredible. It's very powerful, and it's important. It affects lives. It changes lives. It maintains life.
Civil and mechanical engineering students from Rice University are heading to El Panama, Nicaragua, an isolated village south of Managua, the nation's capital. There is no electricity in the village. The team has come up with a plan to light the village church so it can also serve as a community center. The design must use locally available parts, withstand torrential wind and rain, and last for many years.
Back in the United States, I'll take luxuries for granted. The things I have, the things I eat, the things I do. And I'll come to Nicaragua and realize that they don't even have lighting to light their own church at night.
Currently, if they want to run anything electric, they've got to rent a generator, buy gasoline, carry it through that huge gorge, get it all the way up here. It's a real undertaking, and it's quite a shock.
What we're able to do here for them is provide electricity via solar power, which is a very sustainable design. It just so happens to be their church building, but it will become a community center for them where they can have gatherings at night. In speaking to community members, they are very grateful to have something like that. Muchas gracias.
This wall over the top, and we skirt on the inside.
Yeah.
We are making our final determination of where we want to place the solar panel in a way that we'll get the least amount of shade on it, and so we can get the most sunlight at all times.
Right there. Engineering is definitely cool. You can learn all sorts of things in textbooks, but until you get out here and you apply it and you start screwing pipes together and all that sort of stuff, you're not going to really be able to make a difference in the world unless you apply all that theory. So that's what engineering is really special to me.
Okay.
The only thing we'll be losing would be the contact here and here. There's 4 contact points.
I could be back in the States right now, just breaking and just relaxing, but being here and helping these people and seeing the kids and seeing the gratefulness of the community is just so much more rewarding.
The village of Giri in Ghana, Africa, has no running water or toilets and no electricity. During the rainy months, heavy flooding prevents the villagers from using the path to the train station. Farmers are unable to get their produce to market. Children are unable to get to school, and the sick are unable to get the health care they need. Civil, structural, environmental, and mechanical engineering students with the University of Wisconsin-Platteville are designing a solution. With the help of project mentors, they've been considering everything from a floating bridge to a cable suspension structure. It's essential that the bridge be inexpensive, long-lasting, and easy for the village to maintain with locally available tools and materials. The team has decided on a reinforced concrete pedestrian bridge. But with Ghana's rainy season coming and commitments back home in the U.S., they have to build it in only 2 weeks.
You will be part of the team that builds this bridge, this entire bridge that's in this plan. So, yeah, this reinforced concrete design is expected to last for decades. Realistically, in 50 years, my children should be able to go back and visit the bridge that we helped construct, and it should be in the same condition that it is today.
Okay, one thing that we got to keep in mind on this project is that we've got to complete it. If we got things that go wrong, we're going to have to make sure that we make up that time, because we can't leave this project without having it completed.
You wouldn't normally see a bridge built in, 12, 13 days, but we're going to get it done because of the energy that we have and the energy that the community has. together, it's just really explosive and exciting to work with everyone.
The country has 2 rainy seasons, and during them, this little tiny stream becomes, it's not a raging river, but the water is far too high for the children to make it to school. The walk for anyone who has a job in the city to the train station goes from a couple hundred yards to 5 or 6 miles.
This bridge means a better way of life for this community, absolutely. They can sell their goods, they can get to the city, they can get to the doctor better. Most importantly, they can get to school, so hopefully we'll be bringing up a new, more educated generation.
They understand that there's a big world out there, and so the least we can do is build a bridge so they can get to school. It's very emotional. From the time you pull in here with the van in the morning and see all the kids coming and waving, it's particularly emotional to me, and it will be for these students.
Meanwhile, back in Namawanga village, community leaders have selected sites to be tested for drilling a new well. The UMass team must search deep underground for a sustainable aquifer.
This resistivity meter looks into the ground to find Maji Safi, which is clean water in Swahili, and it looks into the ground to find out where the bedrock starts and where the what different soils are there, and basically where the water starts, because you can find out the resistivity of the soil, whether it's water, if there's water in it, if there's groundwater, or if there's cracks in the bedrock below.
5, 10, 15. Isn't really the deepest out.
In other sites around the village, engineering students are investigating water resource contamination. Chemical fertilizers and waste from grazing cattle have been impacting the groundwater.
We are going to be testing the water here. This device measures some of the basic elements that engineers and scientists test usually in water.
They found no problems with arsenic or fluoride, but they are also measuring other levels such as dissolved oxygen and pH.
Okay, the temperature is 23.58 degrees Celsius. Conductivity is 0.190.
It's clean. It's very clean. So it's good. It's good water. Good water. My recommendation would be to put a fence up around this area.
To protect it.
Exactly.
Yeah.
Okay.
Yeah, thank you.
You're welcome.
This is a basic springbox improvement. Behind you there is the concrete wall that acts as sort of the end of the springbox. These posts are going up all the way around in a nice big wide radius to control animals from walking right on top of this area here that eventually is going to be mounded. It keeps the water source cleaner so it doesn't get the bacterial infiltration.
Thanks for what we are doing. Thank you for helping.
This type of work, being able to impact people this way is, I mean, I can't think of anything more important, anything more satisfying to go home at the end of the day and really feel like you did something that matters.
It's this type of work that that is why I like being an environmental engineer, because you get to go in the field and take water samples, climb in and out of ditches, study springs, and do hands-on work. Water is a serious problem in Kenya and in most of Africa, so we're hoping to help them as much as we can.
Yeah, people do die from water around here, drinking bad water, and it does bring a seriousness to our project.
Yeah, we drink water, but when we drink, they will upset our stomachs. We get cholera. We get cholera and typhoid.
Typhoid.
Yeah.
From the water.
From water.
From water.
Because it is impure. Even the child. But we are showing it that it is pure. See how the problem we have.
We drink.
Because there is no way out. Yeah, there's no way out.
The missing ball.
Here we are in a village in Nicaragua, meeting locals and having lunch with them as chickens and pigs run through the dining room, and building a solar panel that'll really help them in a profound way.
Yeah. Sweet. It's supposed to have a potential of 20 volts and have a current of maybe 4 amps. So we were just making sure that that was so. And yes, it worked, which is good news for us because it's New Year's Eve, so we wouldn't really be able to go back to Managua and get another solar panel. So panel working is good news.
We're gonna put it up now?
This is pretty much the moment we've been waiting for, is just get it up in the air. Now we gotta get the concrete and just make sure it stays that way.
Bien, bien. Nosotros aprendemos de usted y usted no.
Good, good. It's been good.
Estamos bien en conjunto.
We're working hand in hand and learning a lot from each other.
I think, yeah, everybody's pretty hyped and we're ready to get this finished. Yeah, we have a battery.
Oh my god. Oh my god, it's working.
Now that the battery works, it's time for the moment of truth.
Russ, you want to turn on the light?
Sure. Can we do it together? Uno, no, on a countdown. 3, 2, 1. Nada.
What'd we do?
Is it the wiring? The solar panel? The battery?
Well, kind of disappointing, I'm not gonna lie, but hopefully we'll be able to figure out what the problem is before we leave today, so then tomorrow we can implement the solution. If I don't even want to think about if something goes wrong.
You know, the first pour that we do in any community is complete pandemonium, and this probably looks a little bit crazy too, but it takes a while for everybody to figure out what their role is, and then after everybody figures it out, it almost is like a little ballet.
Probably a third of our workforce is children, and probably decades later they'll be talking about how, yes, I helped build this bridge.
Up to now, the weather has been cooperating. But after an unseasonable rain puts a halt to the bridge work, the engineering students and villagers must put in grueling 12-hour workdays.
It's raining and it's wet, but it's good.
It's crucial. Every concrete pour without a day of rain, if we can get in with the rain and successful and no failures in any equipment, it's a successful day. It's hard to stop once you start pouring concrete. If you have to stop due to a failure, it's kind of a disaster.
1, 2, 3.
To help make up time, the team divides into smaller groups, working on different parts of the bridge simultaneously.
I think the whole idea of building this bridge was to enable kids to be able to go to school regularly. Families wanted to travel to the nearby urban areas to engage themselves in economic activity, and they couldn't do that. Some wanted to access, health facilities, and they couldn't do that. So this bridge, I think, is going to go a long way, to improve, the quality of life for the community.
Having kids tell me how they're going to be able to go to school. Everyone goes to school in America, basically. To have a place like this where it's a privilege for them to go to school, and for us to give them the opportunity to go to that school, it's just amazing.
With a reprieve from the rain, the team and the bridge are back on track. But storm clouds still loom on the horizon. As Kenya's presidential election draws near, the UMass engineering team has returned back to campus to review water testing data and to design the new well for Namawanga Village.
We found presence of bacteria in the water and we have some numbers. However, we need to work a little bit more to understand how we can diminish these numbers.
We don't have to carry our water for 2 miles. We don't have to boil our water in order to make it safe to drink.
I calculated all the flow rates that we had taken in January. And we can compare those to the ones that we took in March and put them on a map. Those are all our spring boxes. Flow rates in liters per minute. So you have 310 up here. And then there's a nice concentration right around Kifa and Namawanga, 115, 160.
There are a few challenges. We have to find a drill company. We'll need to figure out which type of pump will be best because we do not want to dry up the aquifer that we'll be getting the water from. And also, the village would really appreciate if we learn Kiswahili better for the future trip.
They are very smart people in an area where they just don't have, frankly, the money to put something together, even though the resources are available to do that. So there's some challenges ahead.
Violence erupted today in Kenya as supporters of opposition candidate Raila Odinga.
Post-election violence in Kenya results in the deaths of more than 1,500 people. Many thousands are displaced. Transportation and other critical infrastructure are affected. With the situation still volatile, the engineering students are not allowed to travel back to the village. But they are able to coordinate the implementation of the well from the US, communicating mostly by email. Eventually, the travel restrictions are lifted and the students are able to return to Namawanga as the village celebrates the new well.
It may sound silly, but I mean, it's some hope. You know, a good water system can improve the infant mortality rates overnight. As soon as you can measure a difference, it's measurable. And it's a phenomenal thing. It's a wonderful thing. We have the technology. We're able to do it. The will is there. I just think more people should start doing this because it's doable.
Back in El Panama, the Rice University team continues to troubleshoot the electrical problem. They trace and retrace their steps.
So basically, you've got positive coming out of the white here, and then you connect it to another white. The white from the socket is a negative.
It was
So you need
just
to
saying on
connect
the
the positive.
fixture, if one works, then it's the switching things. If this one is the only one that lights up, we know that we have to go back and switch the negative and positive of the light fixtures. Yeah.
The students have narrowed it down to a wiring problem. The team double checks all the connections and makes one last adjustment.
Well, okay, let's try this. Let's try it again now. It's you and me. Let's 1, 2, 3.
So yeah, it just feels great to actually get it done and know that it's going to work and we're actually doing something that really helps some people out.
I guess this is real engineering. You know, you come from the design stage to the implementation and work out all the bugs along the way. So I guess it's just been good for us to go through the process and keep going.
Now they'll at least be able to run 12-volt lights in their church, and maybe with a little modification they could run more appliances. 1, 2, 3, eat out! 1, 2, 3. Uno más.
1, 2, 3. We're going to go down slowly. A little more. Things don't go exactly as planned. And in this particular case, we had one of the piers that had settled a little bit into kind of some softer material. So we had to make a little adjustment. We had to jack up the bridge, the entire bridge up 3 inches so that we could accommodate that little bit of settlement. So it's good to work through these kinds of things because they're part of engineering life. And it's a good life lesson as well as a good lesson downhill.
Slide out, slide out, slide out. Okay.
Once the deck falsework has been raised, the team must carry the steel rebar cages to the bridge site. They are so heavy, it takes more than a dozen people to set them in place.
10 inches this way. Good.
Perfect.
The rebar cages will be used to reinforce the concrete beams on both sides, strengthening the structural integrity of the bridge and making it safer. The team makes its final adjustments in preparation for a massive concrete pour.
Together we build.
Yeah, exactly,
We
together.
form.
Yes.
It is good that you brought your family to my village. I'm so happy.
Yes, and I'm so happy that your family wanted to work with us.
Oh, yeah, I see.
It always makes me feel much better when the whole community works like this. Yeah, it makes the project much better.
Okay.
Much better.
Okay.
Okay, you guys, this is our last concrete pour. Let's make sure that we're being safe. Have a good completion on the concrete.
Okay, let's do it together. Yeah, Mama. Amen.
When we get done with this, you know, the community's going to be, wow, we never thought we could build a bridge, but they did, right? They did it. They're the people that did it, so now they're going to know that they can do a lot of other things. Whatever else is important to the community, you know, whatever other project they've got. So that is, a lot of times it's more than just the project. It's empowerment of people working together.
Despite the rain, the language barrier, and adjustments in the field, the villagers and engineering students have built the bridge in time for the approaching rainy season.
Maybe in 10 years, that 3-year-old girl that saw that women can do this, and we're all working together in a team, and they can help build their country up from the inside.
Good work. Good work.
It is a huge sense of accomplishment to be able to come and build a bridge in 10 days. It just doesn't happen everywhere.
Well, it's really great to have the bridge done. I mean, already you can see people walking across with water on their heads. The bicycle man just went through, so it's just great to see them being able to use it and being happy about it.
It's great to actually have a physical object in the bridge, something to look at to say we've accomplished, but I think the sense of accomplishment will come when we come back next year and all the kids can actually say they've completed a full year of school without missing a day. That's the true accomplishment in this project.
The engineering students and villagers have bonded together and become friends. As the team says its goodbyes and prepares to return to the U.S., they're looking at new projects that will continue to build the local infrastructure.
Whether it's drinking water, whether it's waste treatment, whether it's the building that you live in, whether it's the road that you travel along, it's all from engineering. So without engineers, you can picture how the world is going to look like.
I don't know, aside from medicine or being a doctor, I don't know any other field where your project has such an immediate and positive impact on people.
You're helping people. I mean, that's what it comes down to. You're helping people, you're changing lives, you're saving lives, right? Because you're supplying clean water.
I'm not gonna lie, I'm kind of numb right now. I've never done anything like this before. We just built a bridge in 10 days, which is amazing. It's gonna take me a while to process this.
This project, it's going to make a major difference in their lives. It's going to lead to a better standard of living. Just things like that. That's what we're here for.
We are happy to have all you visitors here, and we thank you for coming here. And when you go back there, you remember us. Of course. And you are welcomed here another time. Thank you.
Jambasana.
Jambasana.